All right, here is problem number 4 from the practice test. It says that HPV is a virus that has been linked to the development of cervical and other cancers. Gardasil vaccine for HPV has been available since 2006 and was initially recommended by the FDA for use by women from ages 9 to 26. At the time, the typical Gardasil regimen consisted of a sequence of 3 shots given over a 6 to 12 months period. Current recommendations are for a routine vaccination for all children starting at 11 and for anyone through age 26 who has not been adequately vaccinated. Because patients have to return to the clinic to receive the follow-up shots, medical professionals are concerned about completion rates for the vaccine series. In an effort to learn what variables might contribute to a patient completing the series, an early study in 2008 examined the medical records of 1,413 young female patients ages 11 through 26 in the Baltimore area who came to one of 4 clinics to begin the 3-shot regimen. Demographic information, including patient age, race, type of insurance used, type of practice attended, and the number of shots the patient received and the clinic location was recorded. After the data was collected, researchers divided the patients into 2 age groups, 11 through 18 and 19 through 26 for study purposes. Let's consider the 1,413 patients in the Gardasil investigation as a random sample of female patients from that time period and use the randomization-based hypothesis test to answer the question, are variables of clinic and completion status independent? Let's express the research question in terms of the null and alternate hypothesis. In this case, I believe the null hypothesis, which is typically a hypothesis of no difference, is that clinic location and completion status are independent, meaning there's no difference between the location and the completion status. The one doesn't affect the other. Now, do we think that's really true? No. Well, typically we make the HA claim that clinic location and completion status are not independent. Sort of a hypothesis of not that there is a difference. Okay. Now, calculate the observed difference in proportion of patients from suburban clinics and urban clinics who completed the vaccination. So this is, what did we observe? So it's a p-hat of suburban. And that would be among those people who were in suburban, which was, there was 963 of them, 355 of them completed the vaccination series. So 36 let's call that 36.86. Okay, what about those in the urban clinics? Well, there were, in that case, 114 that completed out of 450. Giving us 20.2533. Now, if we subtract the 2, 0.3686 minus 0.2533, we get 11.53%. 0.1153. Now, if you were going to do this as a simulation, how many cards would we need to simulate this? About 1,013, one for each of the patients that were in there. How many could be green that represent the suburban clinics? How about 963 of them? And then how many of these should be white that represent the urban clinics? How about 450? So we're going to simulate this with this deck of cards. Okay. Now, after we shuffle the cards, how many should be in the things representing people who have completed the series? So this is leaving up to random chance alone. Random chance alone determining if you completed the series. So what we would do is, how many completed the series? 469 of them. 469 completed the series. And then the pile that's left over would be those who did not complete the series. That would be the 944. Okay. Then we calculate the difference between those proportions. All right. Between suburban and urban. Now, if there's no effect, we expect that those who completed in the suburban group and the urban group to be zero. The difference to be zero, that they're the same. There is no difference. Okay. Then we look at the dot plot of observed differences. Okay. The observed difference that we saw was up here at 11. How many times by pure chance alone did we get an outcome of 11 or more? And the answer is, it didn't happen. It didn't happen by chance. Not once in the simulations. How many were in the simulation? Can't tell, but it was zero. So we would say that this represents extremely strong evidence that the null hypothesis should be rejected. It is not a good fit for the observed observations.